This tutorial is looking at degrees and radians. You might want your calculator in hand for this. I've got some of the answers written down already, so let's get going. If we're converting angles in degrees to radians in terms of pi, we need to multiply by pi over 180. So that's not too bad. That's just going to become, what's the best way to write this? I'm going to simplify a little bit now. 30 pi over 18. If we want to just kind of chunk that down, we could get 15 pi over 9, but we can keep going. 5 pi over 3. You can't jump straight to that as your first answer. Just thought I'd show you the way that I'd kind of work through a little bit. 71. This one's nice and easy. 71 pi over 180. We cannot do anything else with that. Example 3, converting the following angle to degrees. That is where we multiply by 180 over pi. That means our pi's cancel and we're left with, and actually we can cancel 180 with 6 giving us, I think that's 30. Yep, and 7 times 30 is 210 degrees. Very important that we're stating that degrees. If you were doing this with a decimal, you would have a CAS calculator with you, so I just typed in 4.61 times 180 over pi, and that gives me 264.13 degrees. This is your intro to the unit circle. Hopefully you've seen this before, but check it out here if you have not. These are where we're getting these values from. Hopefully that helps you kind of picture what you're doing over the next few weeks. When we're looking at arc length, there is a formula, length equals radius times theta. And our first step is to convert our angle, so in this case 75 degrees, I might write in another color here, to radians. And what that does on the calculator is it gives us 1.3090. 4 decimal places is what we were told to use here. If you're unsure how to do that on your calculator, check the float in your settings. That will tell you how many units you will be given. So you need to set that to maybe 6 or something to get that many decimal places or get close to. Same thing here. If we were using the arc length formula to find, oh, where's my question gone? Yep, so we've got our value, and now I'm using my radius of 8 and multiplying it by my angle in radians, 1.309, which gives us the length of 10.472 centimeters. Must state our units, of course. Same kind of thing here, converting to radians, so that is 65 times pi on 180, which gives us 1.1345, multiplying by our length, gives us 15.883. So that is how to do arc length using the length equals radius times theta, and theta must be in radians for this formula to work. Really quick lesson. There's actually another one of these on the Maths Factory looking at how to use your calculator for some of this. So if you're still unsure, check that out. Hopefully it all makes sense by the end of those 2 videos.